Hello, welcome to the first video lecture. Today, we're going to talk about operations on functions. Functions, like any type of real number, we can do a bunch of different algebraic operations, like a sum function, where I have f and g, and I add the two resulting functions, f of x plus g of x. I can have a quotient function, a difference function, f minus g of x, right? This notation is just really going to mean f of x minus g of x. Right? If I have a product fg of x, that will be their product function, f of x times g of x. And then I have the quotient function, f over g of x, will just really quite end up being f of x divided by g of x with one condition, that g of x is not 0. Right? We've said kind of before that we really never want to divide by 0. There is a fifth type of operation, and this is called function composition. And the composition of functions f with another function g, right? We denote f o g or f circle g. We define it by f composed with g being f with actually g of x plugged into it. And we've spoke about this before when we did section 4 about function notation. F of g of x will quite literally be taking the instances of x in the function f and replacing it with the entire function of g. Right? That's exactly what we want to do. So, let's look at a quick example of that. If I have f of x being 3x plus 1 and g of x being 2x divided by x minus 1, I want to look at f composed with g. We said f composed with g is quite literally f of g of x. Right? That would quite literally be f of 2x divided by x minus 1. I want to take the instances of x in f, which is this, and replace it with that entire quantity. So instead of 3x plus 1, it's 2x divided by x minus 1 plus 1. The only simplification I would ever ask is that we take this 3 and multiply it. Right? We can multiply it by this 2. And you get 6x over x minus 1 plus 1. And this would be a perfectly acceptable answer. Let's move on to the next one. If I take g of f of x, that is quite literally taking g and plugging in f of x to it. Right? That'd be like taking g, and for every instance of x, I replace it with the value 3x plus 1. So I take my 3x plus 1 and replace it for these instances of x. So it's 2 instead of x, 3x plus 1, divided by, instead of x, 3x plus 1 minus 1. And then if we simplify that, we'll distribute that 2, 6x plus 2, divided by, I can drop that parentheses, I have 3x plus 1 minus 1, and I just get 3x. Right? And that's my answer. All right, if we move on to this last example, we have f of g of 3. And what we notice is we've already computed an f of g of x. Right? We found that to be 6x divided by x minus 1 plus 1. And I can use that function, right, that brand new function, to find f of g of 3 by just plugging 3 in. Just like that. I'll get 18 over 2 plus 1, which is 9 plus 1, which is 10. All right, let's do an example of the other ways we can compose or bring about two functions. So if we let f of x be 2x minus 1, and g of x be 3x plus 5, we want to find these three things. So we said if I want to find f plus g of x, that quite literally was just f of x plus g of x, right? It's the function that results from adding these two together. So I'll take my 2x minus 1 and add my 3x plus 5. Right? I put parentheses around them to make sure I am not missing any type of distribution or multiplication. And I notice that these are in fact unnecessary parentheses. So I can just drop them, 2x minus 1 plus 3x plus 5. And I can just add them. And I'll get 5x plus 4. And that would be the function that results from their sum. Let's move on to the second example. I want to find fg of x. And we said fg of x quite literally was just f of x times g of x. So that would be 2x minus 1 times 3x plus 5. And again, we're putting parentheses around the functions, and hopefully we notice how important that is in this case, because it's letting us know that when we multiply these functions, we're actually having to FOIL. So if I FOIL, I'll get 6x squared plus 10x minus 3x minus 5, and my resulting function will be 6x squared plus 7x minus 5. If I move on to my last example, f over g of x, we said that was quite literally f of x divided by g of x, as long as my g of x was not 0. And in this case, we can see my g of x is not 0. So this will just be 2x minus 1 divided by 3x plus 5. And when we get here, we want to do like we did with anything else. We want to see if things can simplify. And in this case, there's nothing to factor, right? There's no factoring. So in fact, this is actually as simple as we want it, as simple as possible. So this would be our answer. All right. Hopefully you found this video informational, and I will see you all in class.